This presentation will continue with the example of the syringe inventory analysis, and in this case we'll look at the system of aggregating the inventory into a centralized system, and we'll see how much safety stock is lowered, by how much the holding costs annually be lowered, and then we'll do a comparison of the two systems. So in any case, what we need to do is start out by simply aggregating the demand. So on a week by week basis, we have the value here of the sum. I'm going to just do the sum of these three values. So here we have the weekly demand, just like we had the weekly demands here for the three. Now we're aggregating them, and now we're going to aggregate the weekly standard deviation. Here's where I don't want to hardwire this, because I'm going to come over here and I'm going to write the value right here. I'll say R equals, and I want to make that a Greek letter because I want to show the value of rho. And let me put that over there. And in the problem, the first value is 0.5, but I know for a fact that in the secondary analysis, we're going to assume that the demand is independent across the products, and we'll be changing this to 0. But in any case, let's start by doing the calculations for the aggregate standard deviation. And it's a pretty lengthy calculation. It's the square root of the sigma squared for the first value here for the first department, plus the sigma squared for the second department, plus the sigma squared for the third department, plus 2 times rho times sigma 1 from let's call it sigma A here, times sigma B, plus 2 times rho times sigma A times sigma C, plus 2 times rho times sigma B times sigma C. Alright, take a quick look at that. We have 2 times J1 3 times. We have B3 times C3, B3 times D3, and C3 times D3. And we have B3, C3, and D3 squared. Oh, right here. Looks like I cubed that number by accident, so let's fix that. And then we get a value of 1008. Now we can then do actually we can do a lot of, remember that we did these values here before. We can basically take this column of numbers and just copy them here. So, we have 3 times the demand. We have the standard deviation, which is the square root of 3 times the sigma, because we are independent across periods, not to be confused with independent across products, which we're not here. Then we have the value of the CB, which is standard deviation over the mean. We have the value of f of k, which is 1 minus the 0.99 service level times the CV. We have the table lookup of 0.136, and just so you don't believe me, 0.136 right there, 729, and then we multiply 729 times standard deviation to get the safety stock, and then we have the holding cost, which is the value of 0.25 times 1.75 times the safety stock. Oh, that was nice. Spreadsheets are cool. Now we can come over here and we can just kind of say, put a label right here, savings. This is savings for the centralized system, and let me just put that there. And so these values will be equal to the decentralized minus the centralized. So we'll have that much less inventory for syringes on an ongoing basis, and the cost savings will be $474. Alright, so there's your key result right there, the $474 savings. Okay, and we see how we did the aggregation here. And life is pretty simple if you know the formulas and you're a little bit proficient with Excel. One of the things that's nice about it is that there was a secondary question, which was the question, how would these results change if the demand across the three products was independent? And the answer to that would be obtained by looking at rho equals 0, and we see a savings of $573. You could look at rho equals zero point 0.6 with a high correlation, you get very little savings. You get a negative rho of say minus zero point 0.4, and you get a bigger savings because of the negative correlation which was discussed earlier. Alright, so let's just put it back to the 0.15. And so that's how we analyze the decentralized system, and we then compare it with that's how we analyze the centralized system and compare it with the decentralized system.